Next, we have a concept for design for X. So the word X stands for one of these many things. It can be, X can be replaced with A, which means design for assembly. Or it could be replaced with E, design for environment, or with M, design for manufacturability. So what's all this stuff, right? So the product definition, that is how a product will be used, what its function is, what is its range of properties, what is the probable range of cost, what aesthetic features. These are a lot of things that the designer has to try to optimize simultaneously. Now, in addition to this, there are many other product attributes also that the designer or the design team should be concerned about. These are attributes that can cause the product to succeed or fail. It is to take care of some of these attributes that we have come up with the concept of design for X. For example, design for assembly. What does that mean? It's a set of rules or guidelines that will help you to make sure the parts assemble. Take a car, it's made up of thousands of parts. They are not standalone, they have to be put together. Each part may be individually good. Each nut, each bolt, each washer, or each O-ring is good, but you try to slap them together, they don't seem to fit well. Well, finding out after you made all these parts that they don't fit well, we got a problem there. So we need to think about assembly even as we make the part. We don't. Think about manufacturability. What does that mean? It means that certain things are okay from a design standpoint, from a functional standpoint, but to try to make the stuff would be very difficult. Because you can't, maybe you need a casting process, but the metal may have a high melting point. That means it's very difficult to melt the metal. It doesn't pour well into a mold. So thinking, or two pieces of metal may not weld very well together. So thinking about how good is it in terms of being able to machine it, weld it, cast it during the design stage. Those guidelines are called design for manufacture. So design for X is a set of guidelines to make sure that many product attributes are thought of or considered during the drawing board or design stage. So within this mix, we now have more recently added DfE, which is design for environment. Now, it's not that only now we are thinking about environment. We have thought of environment over the last 2-3 decades in one form or the other. But earlier, our thinking was not holistic. It was simply thinking about environmental compliance. You have EPA and you have various state regulatory agencies, and we only thought of environmental issues from standpoint of compliance. And so there's a difference between standpoints, right? So how it differs is as follows. So if you are only focused on compliance, so this is the entire product cycle. You have virgin material extraction, you have material preparation, components are made, then they go into the factory. This is the line. It goes into the factory through the walls, the materials are processed, some modules are assembled, and then they are put together, and that's how you get your product. So this is the assembly for your Ford plant or GM and so forth. Then they leave the factory through this dashed line, they are packaged, they are shipped, and then it goes to the consumer. So it's a whole life cycle. In the past, environmental compliance was focused only within the factory walls. From when we started doing module assembly, processing some materials, and then slapping them all together as you would in a typical automotive plant in the assembly line. We didn't bother about what happened before. We didn't bother about what happened after the product left the factory walls and on to packaging, shipping, and then use. So design for environment looks at the whole life cycle. Environmental compliance is limited. It just looks at, does the plant release a lot of, from its smokestack, does it release a lot of gaseous products? Does it release a lot of bad liquid effluents? Now that's important, but we need to think about the entire life cycle, and design for environment helps us do that. Now, how do we implement design for environment? Well, many of the DFX, like design for assembly, design for manufacture, design for service, etc., are currently being implemented in many organizations. And so the easiest form of seamlessly including DFE is to make DFE a part of the company-wide DFX approach. After all, they have others that are ongoing. Just add a new module. Some companies use CAD/CAM, their computer-aided design, computer-aided manufacturing. It's all software. So try to include DFE as part of the CAD/CAM system. So these are ways in which you can ensure that environmental considerations will be forcibly incorporated during the design stage and doesn't fall off the radar. Now, a couple of things before we close. We talked about product design and how it's a team-based approach. It's not like Henry Ford or Wright Brothers or Edison. Products are too complex. The development takes a year or more. You need a whole lot of specialists. And so we have the concept of a product design team. So in addition to the usual culprits, various kinds of engineering specialists, right? You got a person who does air conditioning design, you got a transmission design team, you got the suspension design team. So you need all of these people, but you need more than that. You need marketing people. A well-designed car that body panel doesn't look pleasing, or it's got an awful color like the color of Pepto-Bismol, kind of pink. No matter how good your engineering is, most people don't like that color. There may be a few who are really going for the Pepto-Bismol looks. So you need a marketing specialist in there, and then you need a manufacturing specialist who stops you and say, okay, all of this is fine. Do you know what it's going to take to assemble this stuff together? That's going to be a nightmare. You need some finance people telling you, hey, wait a second, have you thought about costs? So you have to include all of these people and have them review the designs together, not one after the other, because that's a very long process. So because we have these teams, the best way to make sure environmental considerations are incorporated is to include an industrial ecology or an environmental engineer in this team. That way you can make sure that every time a review comes up, we're asking questions related to environmental performance.